The Voyager 1 space probe, humanity's most distant traveler, has been sailing through the cosmos for more than 40 years, and even now it continues to surprise us with breathtaking revelations. Originally launched in 1977 as part of NASA's Voyager program, the spacecraft was built to conduct flybys of Jupiter and Saturn, capturing images and data that no human eye had ever witnessed. At the time, mission planners expected it to last no longer than 5 years. Yet here we are, nearly half a century later, and Voyager 1 is not only still alive but is also delivering discoveries that stretch the limits of our imagination. Recently, scientists reported something astonishing. Voyager 1, now operating far beyond its original targets, detected more than 300 mysterious objects drifting silently across the endless expanse of deep space. These strange entities appear to be plasma-based remnants, possibly the debris left behind from ancient stellar detonations that occurred millions, if not billions, of years ago. Their detection has reshaped scientific conversations about the processes that sculpt the interstellar medium. Are we seeing the ghostly fingerprints of collapsed stars, the ashes of supernovae scattered across the galaxy? Or is this something entirely new, a cosmic phenomenon never before encountered? To truly grasp the magnitude of this discovery, we need to understand just how far Voyager 1 has traveled. In August of 2012, it became the first human-made object to cross the heliopause, the boundary where the influence of the solar wind ends, and the vast ocean of interstellar space begins. Reaching this milestone was no small feat. Within the protective bubble of the heliosphere, Voyager was still under the influence of our Sun, surrounded by its magnetic field and particles. But beyond the heliopause lies a region dominated by matter and energy from the broader galaxy, a realm untouched by our star's sheltering wind. This is the environment where Voyager 1 now drifts, and it is in this alien environment that it encountered the 300 enigmatic plasma anomalies. But Voyager's continued operation has never been easy. As it moves farther from the Sun, the energy that powers its systems has steadily diminished. Unlike satellites orbiting Earth that draw power from solar panels, Voyager relies on 3 radioisotope thermoelectric generators or RTGs. These devices convert the heat released by the natural decay of plutonium-238 into electricity. When it was first launched, these RTGs produced around 470 watts of power. Today, due to the gradual decline of radioactive decay, Voyager 1 generates far less. Each year, it loses about 4 watts of power, forcing NASA engineers to make hard decisions about which instruments to keep running and which to shut down. Over time, many non-essential systems have been powered down to conserve energy. Cameras, for instance, are long offline. The images Voyager once sent back of Jupiter's swirling storms, Saturn's icy rains, and their moons are memories preserved in history. What remains active are only the most critical scientific instruments, magnetometers, plasma detectors, and cosmic ray sensors, tools that continue to provide valuable data even in Voyager's fragile state. Every watt matters, and NASA has carefully rationed the spacecraft's limited supply to prolong its mission for as long as possible. Even with careful energy management, distance poses an equally daunting challenge. Today, Voyager 1 is more than 14 billion miles from Earth. A radio message sent from the probe takes over 21 hours to reach us, and another 21 hours for a reply to travel back. The signal itself is unimaginably faint. By the time it reaches Earth, it is a billion times weaker than the power required to run a watch battery. To capture this delicate whisper, NASA relies on its Deep Space Network, a global array of giant antenna stations located in California, Spain, and Australia. Without these massive dishes, communication would be impossible. Despite these hurdles, Voyager 1 has delivered one of its most perplexing observations: the detection of hundreds of plasma formations moving across interstellar space. These structures, invisible to the human eye, were revealed through the spacecraft's sensors. Plasma, often referred to as the fourth state of matter, is a hot, charged gas composed of ions and electrons. It fills much of the visible universe, coursing through galaxies and stars, shaping magnetic fields, and influencing cosmic evolution. The plasma objects Voyager has detected could be remnants of titanic stellar explosions, supernovae that once illuminated the night sky of distant civilizations. If so, then Voyager is sailing through a graveyard of stars, collecting traces of their long-vanished lives. At first, however, the discovery was clouded in mystery. The data that arrived on Earth was scrambled, unreadable, almost as if encrypted by the universe itself. For weeks, NASA's engineers puzzled over the issue. Was it a technical fault? Could Voyager's failing instruments have distorted the signal? Or was there interference from cosmic radiation that garbled the transmissions? Eventually, after painstaking analysis, the engineers traced the problem not to deep space itself, but to Voyager's onboard systems. The culprit was the spacecraft's Attitude and Articulation Control System, AACS, responsible for keeping Voyager's antenna pointed toward Earth. For reasons still not fully understood, the AACS had begun routing data through an old, dormant computer that had not been used in decades. This rerouting corrupted the outgoing signal, creating the scrambled data that initially baffled scientists. The fix required extraordinary patience. Every command sent to Voyager takes almost a full day to arrive, and another day for confirmation to return. Engineers had to consult manuals and documentation written in the 1970s, revisiting technologies older than many of the team members themselves. In the end, they successfully commanded Voyager to resume sending signals through the proper systems. Just like that, communication was restored, and the data became readable once again. The episode was a reminder not only of the spacecraft's fragility, but also of human persistence, the ability to bridge half a century of technology and knowledge to keep our distant emissary alive. With the correction in place, Voyager 1 resumed sending data on the plasma anomalies, giving scientists a rare glimpse into the invisible fabric of the universe. Each cluster detected holds clues to the life cycles of stars. When massive stars explode in supernovae, they scatter heavy elements like carbon, iron, and oxygen into space. These elements then drift across galaxies, eventually becoming part of new stars, planets, and even living beings. By studying the properties of these plasma formations, scientists gain insight into how galaxies recycle their material, and ultimately, how life itself is possible. In a sense, Voyager 1 is tracing our own cosmic ancestry, following the pathways of stardust that seeded our existence. Yet Voyager 1 is more than just a scientific mission. It also carries with it a profound cultural message. Attached to its frame is the famous Golden Record, a copper disc coated in gold that serves as a time capsule of Earth. Curated by a team led by astronomer Carl Sagan, the record includes greetings in 55 languages, music ranging from Beethoven to Chuck Berry, and natural sounds that capture the essence of life on Earth. The crash of ocean waves, the calls of animals, the cry of a newborn child. Etched into the record are instructions, showing how to play it, and a map of our solar system's location. It was designed not just as a scientific artifact, but as a message of peace and hope, an introduction to humanity for any intelligent life that may one day encounter the spacecraft. The symbolism of this is powerful. While Voyager 1 continues to collect scientific data, it also carries within it a reminder of what it means to be human, the curiosity, the creativity, and the desire to connect across the void. Even if its instruments fall silent in the coming years, the Golden Record will continue its journey, perhaps for billions of years, outliving Earth itself and carrying our story into eternity. NASA estimates that by 2030, Voyager 1 will no longer have enough power to keep its instruments running. Gradually, one by one, its systems will be shut down. But the spacecraft will not cease its voyage. It will continue drifting through the galaxy, a silent messenger from Earth, destined to wander among the stars long after humanity is gone. Voyager 1's story is more than a tale of engineering or science. It is a testament to human perseverance, a symbol of our drive to explore, to seek knowledge, and to leave behind a legacy. Each faint signal that arrives across billions of kilometers is not just data. It is a reminder that we are capable of reaching beyond our world, of dreaming beyond our limits. So, as we wait for Voyager 1's next whisper from the cosmos, we reflect on what it has already given us. Images of alien worlds, evidence of interstellar plasma, and a timeless message of hope carved into a golden disk. The spacecraft proves that exploration is not only about discovery, it is about inspiration. It shows us that even the smallest vessel, launched with 1970s technology, can carry the weight of humanity's greatest dreams. Voyager 1 is not just a probe. It is a legacy, a bridge between worlds, and a voice from Earth that will echo through the stars for ages to come.